Welcome back to the next module. We are looking at solids this time. So if you go to the fourth tab, you will see solids. And solids are three-dimensional shapes. Up to this point, we have been working with 2 dimensions. Bases and heights, lengths and widths. We've been focusing on flat plane figures. So for solids, you're going to see a 3rd dimension added in. Solids are shapes that are able to hold volume. So we're going to be finding volume of some common shapes that you see in everyday life. Another word for volume is capacity. So we're looking at how much liquid, if you want to think of it that way. It doesn't have to be liquid. It could be any matter. But how much a shape will hold in terms of volume or capacity. So let's get on into this, and I want to start you out with the anatomy of a solid. And I picked a prism because that is the most basic one. It's the easiest one for me to draw. But I want to begin by putting in the vertices because that will help you to visualize all the parts of this solid. So this is a prism. It sounds like I'm saying prison, but it's prism. It's a rectangular prism. And let's mark off the corners. So we have a vertex here and here. Remember, a vertex is where 2 lines come together to make an angle. So you have 8 of these vertices in this solid. Everywhere there's an intersection, you have a vertex. So this particular solid is made up of 3 dimensions. All solids are, but this particular one has a length, a width, and a height. And I want to highlight those for you. These are used interchangeably, so sometimes the length and width may be swapped, or you may be thinking I would call that the width and they're calling it the length. That's okay, because working with these dimensions, we're usually multiplying or adding, so it doesn't matter about the order when we do that. But to me, this is the length of this prism, and I don't have a very good highlighter. Let me try that again. So there is a length. If you notice, back here is another one. Okay, and then here is a length, and here is a length. So for this particular solid, I have 4 of those long sides. So let me label that for you. I will be referring to this as the length of the solid. And the variable for that is L. And I use a cursive L so that I don't mistake that for a 1. If I wrote a manuscript L, it looks a little bit like the number 1. Okay, let's look at width. That's another one that we're sort of familiar with. So the widths here are this one, this one, this one, and this one. So those are the widths of the solid. And this variable for width is W. That makes sense. Length and width. And we've been working with length and width now for a while, but we've added a 3rd dimension, and I'll make that pink, and that's the height. So we have 4 of those also. Okay, so that's the 3-dimensional part of a solid. There is a height dimension, a length and a width for this prism. And again, let me remind you, this is a rectangular prism. There are other types of prisms, but this one is a rectangular prism. When I was in school, we just called this a box. But the proper name is a rectangular prism. So let's study this box a little bit further and see if we can figure out some more things about it. It is definitely longer than it is wide, and it's looks like the width and the height are close, but it looks like it's a little bit taller than it is wide. I'm not going to put dimensions on it because we really don't need to do anything with it. I'm just showing you the elements of a solid. And I do want to tell you about another key point here. Volume, which is what we're going to be finding, is measured in cubic units. Okay, now when we studied area back in the second module, the polygons module, we talked about square units because we were looking at the number of little squares it took to fill up a space. With volume, you're looking at the number of cubes it's going to take. And let me draw a cube for you. So you would be interested in how many of these little cubes it would take to fill a given space, to fill it up to a given capacity. So this is called a cubic unit. The square unit that we used for area is very different. And then for circumference and perimeter, we just use plain units. Those were just linear units. But volume is always measured in cubic units. So essentially what we're looking at with volume is how many of these little guys could I stack in there, just like so. How many could I stack in there to fill up this space? So we're looking at the number of cubes it would take to fill the space. When I taught math every day and I had the opportunity to do these kinds of things, I always started this unit with sugar cubes. And I would ask my students to build a model. I would give them maybe 50 cubes, and I would ask them to build a model. And some of them were long, skinny models, some were tall, some were short and wide. Different students came up with different constructions for their cubes, but all of them had an equal volume. So it was a really good little exercise to do to understand about volume. Okay, so that's just an introduction to solids and how they're measured. Each formula for volume is different based on the shape that you're working with. So you'll be seeing a lot of new formulas in this module. Okay, before we move on, I need to show you a skill called parsing a solid. And parsing just means that we're splitting up the solid. We're going to need to do a thing called surface area, where we have to visually break the solid apart and make pictures in our minds so that we can calculate areas for each piece. So I'm going to zoom in on this first one, and I want to start this off by coloring in a section. And so let me keep my colors the same so it's not, this is yellow. Okay, so for this solid, I'm going to try to color. This is a disaster sometimes on this little screen. My eyes aren't what they used to be. So here is one face of this solid. Okay, I've parsed out one face of the solid. And I could tell you that this one back here would be another one. And I'm not sure how that would look. Let me go ahead and color that in. No, that's too much yellow. Let me just go with one of them. But you realize that the other side of that box is just like this one. So this particular face of the solid is made with length and height. Okay. length and height give me this yellow parsing. And there are 2 of these. And they're both rectangles. Okay. So there are 2 of those. There's one in the front, and then there's one in the back. All right, let's look at one right here. Let me zoom in on this guy, and I'm going to change colors just so we don't get this all confused. So here is this side of the box, and this one I can draw the other side because they're not touching, they're not adjacent. So here is the other face. So you see that you have 2 of those faces that are made with width and height. And again, I am parsing this solid. I'm breaking it into its individual faces. And that could possibly be a square. I'm going to go ahead and assume that it may be. It's hard to tell without measurements, but sometimes it'll be a rectangle. It depends on how wide this box is. But I want you to see that it's not always a rectangle. It can be other shapes too. So you have 2 square faces on those. So that's a total of 6 faces. Okay, on this bottom one, can you see where the other one needs to go? I've done the sides of the box. I've done the ends of the box. So I need the top and the bottom of the box. So let's do the last one. And I'm not doing a good job of staying in the lines. But I think you get the idea of the top and the bottom of the box. And this is made by using the length and I'm having spelling issues today. Sorry. Length and width. And we have 2 of those faces. Those are rectangular. So my question for you after doing all this is, how many faces does this box have, this rectangular prism? And it has 6. A rectangular prism has a total of 6 faces. And that will always be true. So if you're doing a surface area, you're going to need to account for the 6 faces of your solid. And now that you know how to parse, we will be using that skill quite a bit in this chapter. Okay, I'm going to stop the video, and when we come back, I will show you how to do this for a rectangular solid with some numbers in the problem. I'll see you soon.